Okay, guys, here we go. Last video. Let's do this thing. Number 10 looks big and complicated on the outset, yeah? It's looking pretty gnarly, but don't be intimidated. Just focus in on what's on the left here. It happens to be R or T, big compound statement. But look over here. Here's that same compound statement. Let's break it down. So here I have something that's on the left. Just happens to be R or T. And I've got something that's on the right, which just happens to be a long statement, Q and not P. Second, I've got that same statement I just saw a moment ago, right? That's the thing that was on the right. And then the conclusion was that same thing that was originally on the left. Right here, let's just use some highlighting to sort of see what's happening here. So here, this was that thing that was on the left, right? And then let's use the orange. This is the thing that's on the right, and I see it again here. Thing that's on the right, see it again there. So I'm going left to right. And then what is the next pattern? It's right to left. Wrong, wrong. That is the pattern of the converse, which is a fallacy. So that's an N invalid argument. It's a fallacy of the converse. Okay, number 11. So we're back to English statements. When I see English statements, I first want to just translate to symbols to make things easier to see. Let's use a new color here. Is that brown? So no sayings are weak. Okay, how can I rephrase that as an if-then statement? If you are saying, then you are not weak. Okay, Hercule is weak. This is where it's kind of a weird one, but the way we're going to translate this is if someone is weak. So if you're saying, then you're not weak, but Hercule is weak, and therefore he is not a saying. That's the translation here, the simple translation. So I've got S to not W. Again, let's just think in terms of left and rights. Here, I've got something on the right. I'm sorry, something on the left, something on the right. This second premise, the W, that's the original right, but reverse, right? So that's the negation of the right. And then what's the final conclusion? It's the negation S, but that's the negation of the original left. So that's the negation of the left. What pattern is that? Left to right, negation right to negation left. That's the pattern of the contrapositive, which makes it a valid argument. And this is indirect reasoning. Or you could say contrapositive. Okay, let's go back to black. All fishermen do karate. So if you're a fishman, you do karate. It's another way of thinking about that. Then you have Hachi as a fishman. That means basically F, right? You have someone who is a fishman. Therefore, he does karate. So what do we have here? Something on the left. Arrow to something on the right. Got something on the left again. Same thing. And therefore, the thing on the right. That's just direct reasoning. That's valid. Reasoning. Okay, number 13. How many more we got there? 13, 14, 15, 16, 17. A few more. Okay, 13. I've got an if-then statement. This time, it happens to be math. But that's no big deal. No big deal. Don't be scared. Here I've got if this, then that. So 3x plus 1 equal to 4. That's the first premise. Let's just call that P. So if P, then Q. So we'll call this part this is the P part. This would be the Q part. And then here I have x not equal to 1. That's the negation of the original Q, right? Therefore, 3x plus 1 is not equal to 4. That's the negation of the original P. Oh, look at what you have there. That's exactly what's in your notes. I'm not even going to bother writing the left-right thing because that's exactly what's in your note above. And that is the pattern of... Oh, sorry. That's the pattern of the contrapositive, right? That's valid by indirect reasoning. Okay. Number 14. I picked Japanese and Hawaiian just because I'm part Japanese, part Hawaiian, and later German, just so I don't get in too much trouble. Okay, if you're Japanese, then you eat sushi. Let's write this out. So if you're J for Japanese, then you eat S for sushi. You are Japanese, that's J. Therefore, you eat sushi. That's pretty straightforward, right? That's just plain old direct reasoning. I'm just gonna write direct because I'm getting lazy to write the word reasoning. Okay, number 15. Let's change color here. What do we want? This new purple. Okay, if you're Hawaiian, then you eat poi. You don't eat poi. Therefore, you're not Hawaiian. Okay, again, pretty straightforward, right? If I just changed the letters, if I'd used P's and Q's instead, you would have seen that it's exactly the same pattern as the contrapositive. If you want to, you can translate from left and right. So I've got left, arrow to right. Second one is the negation of that right side. And then I finish with the negation of the left side. That's the pattern of the contrapositive, which makes it valid. And that's indirect. And I used the same color twice in a row. Sorry about that. Let's switch before I forget next time. Okay, number 16. This example comes from an actual episode of the original Star Trek, which is like, how many years ago now? Oh, it's like a long time ago now. Yeah, it's like over 50 years or something like that. Wow, it's crazy. Okay, anyways, if Mr. Scott is still with us, then the power come on. So we'll say S for Mr. Scott's still with us, P for power comes on. And then the power comes on, therefore, Mr. Scott is still with us. This is a statement that, and this is what happens. So this is Spock speaking, right? He makes this statement in the beginning, and then the power comes on the ship, and then he says this. And, he's a Vulcan, so he's supposed to have impeccable logic. But the writers of the show, I think they made a mistake here because this is an invalid argument. You've got the premise, left to right, but this is right to left, right? We're going in the backwards direction. That's an invalid argument. Oh, come on. Oh, I think I'm writing too close to the edge, maybe. Oh, no, there you go. Invalid. And what fallacy is that? That's the fallacy of the converse, yeah? Converse. Okay, number 17. If you're German, G for German, then you eat sausages. S for sausage. You're not German, therefore you do not eat sausages. Sounds kind of reasonable as an argument, but what's wrong here? I went from left to right, but then the second one is the negation of the left side. And I finish with the negation of the right side. What pattern is that? That's the pattern of the inverse. So that's invalid. Fallacy of the inverse. Okay, number 18. Form a valid conclusion using all the given premises. If you love monkeys, then you will change your name to King Kong. Okay, so for these last two, we're creating the conclusion, following the natural conclusion. So if you love monkeys, we'll say M for love monkeys. Then you change your name. Second one is you love monkeys. Therefore, this is pretty obvious, right? We're going left to right. We've got the left. There's only one natural conclusion, which is the right side. In this case, C for change your name to King Kong. Now, this part right here, this work, that was just to make things clear to myself. But the question was given in English, so my answer should be back in English. So what is the answer? Therefore, you will change your name to King Kong. Okay, so that is the answer. Number 19, again, form a valid conclusion. Let's translate first, though. If you drink boba or ice cream shake today, then today is a good day. So if you drink boba or an ice cream shake, then today is a G for good day. Today is not a good day. Okay. So that's a negation of G. Negation of G. So this is left to right. Here I've got the negation of the right. So that's starting the pattern of the contrapositive, it looks like, right? That means the natural conclusion is going to be the negation of the original, B or I. Now you actually have a couple options here, because when you negate an or, remember that's actually a very special pattern that we can use De Morgan's laws to unpack. So there's two ways to write it. You can write it as it's written right there, or you can unpack it using De Morgan's laws. If you unpack it using De Morgan's laws, that would be negation B, negation I. Remember De Morgan's laws kind of separates those into individual negations, and it just flips the middle. So that would be and. Now let's look at both of those answers in English. Let's do this one first. So how would I translate that? Therefore, B is for you drink boba, right? And I is for you drink ice cream shake. Therefore, you do not drink boba or an ice cream shake. Right, that's what it means. You did not drink either, in other words. Yeah? You do not drink boba or an ice cream shake. Now, what does that really mean, though? So equivalent way of writing that, this way, right? Yeah, let's do that. Let's say this one is in black. We're going to translate that one. They both mean the same thing. You can use either one. Either one's correct. Therefore, you do not drink boba, and you do not drink an ice cream shake. And if you think about it, both those things mean the same thing, right? If you not drink ice cream if you not drink boba or ice cream shake, that means you did not drink boba and you did not drink an ice cream shake. That means the same thing, right? Just two different ways of phrasing that same exact thing. And then looking at that, it makes sense that is an application of De Morgan's laws. It does make sense that those things are logically equivalent, because those do mean the same thing, right? So either form of the answer is correct. If you're doing it the first way, make sure that you have the parentheses. Without the parentheses, it is actually wrong. So you do need those parentheses there, because you're negating that entire compound statement. Or without the parentheses, then you've got to use De Morgan's laws to break it up into two. Now let me give you what another wrong answer would be. If you said negation B or I, just like that, that's wrong. Because this negation is only being applied to the B, but it should be applied to this entire statement. So you need the parentheses, or else you need to apply De Morgan's laws to break it up. Okay? So yeah, that's just a common common type of error that I would see. And just like that, guys, we're done. We're done. That was actually longer than I expected. But yeah, thanks for sticking with me. Hope that made sense. If not, feel free to ask me questions. Have a good one, guys.